It's a diamond lattice structure, right? The diamond lattice structure is different from the other types of structure. It's a special type of crystal structure. Because we not mentioned from the 7 types of crystal systems from this. So this is special types. Because the lattice we know that here to form is sub-lattice, right? So the diamond lattice is formed by the carbon atom in the diamond crystal. We know that one of the types of carbon is a diamond, right? Graphite, diamond, fullerenes and carbon nanotubes, right? These are to form of carbon atoms, the only for carbon atoms. So the diamond is made up full of carbon. So consists of two interpreting phase center cubic Gravis lattice, right? This structure we now discuss from Gravis also. Gravis we get in 14 types of unit cell in the form of 7 types of crystal systems. We not discuss from this, right? So here the phase center is a form of interfacial formations, right? That is we call it as sub-lattice. Lattice we know that the atom is formed in a perfect manner in a periodic formation. That is called as a lattice, right? But sub-lattice is a special case of lattice, right? So it's a form of this body diagonal of a cubic cells. It also is a cubical formation, right? So the denominator very simple, we have calculated the APF, right? Then it's a form of 1/4 the length of the diagonals, right? 1/4 the length of the diagonals means this is diagonal, right? In the quarter portion is this. Take a 1 cubic. The cubic will be cut in 4 portions, right? The diagonal is same. We take up 1 portion of 4. Are you clear? Right? The cubical structure is a cut of 4, right? 1 unit cell is a form of 1/4 the length of the diagonals. Next one. Look at that. We know that the atom, right? One is normal atom, another one is an base atom, and another one is in a diagonal formation of that smaller portion of base atoms, right? That we discussed. So the example of the diamond is a form of silicon, germanium, carbon, and tellurium possess this structure. It is all combined to the form of diamonds, right? Most of its form of carbons. Then combination of two interfacials. What is that? FCC sub-lattice. You got it home. We discussed only for the lattice, but now we discuss from what is that? Sub-lattice. Right. So the sub-lattice origin is start from what is that? 0, 0, 0. In all the cubical structure, the start from the lattice point is a 0. Right? I think you know that this is a Miller indices. Miller indices. Right? The next one, the other at the point of the way, it's a body diagonal. It's a form of what is that? A by 4. A we know that is the side of the cube, but A by 4 it becomes a quadrilateral. Quadrilateral means 1 by 4. So the A by 4, A by 4, A by 4. Are you clear? How we get from this A by 4? Then it becomes forming what is that? Loosely packed structure, because the final answer we get it only for 34%. Right? Next one. So the types of atoms. Are you clear? First one, the corner atom. The corner atom we get 1 by 8 into 8 equal to what is that? 1 atom. So the number of corner atom per unit cell, what is that? It's a 1. Right? Next one. Yes, the number of phase center atom. Right? Each phase center atom is what is that? Shared by 2 unit cells. Right? So the number of phase center atom per unit cell, how much we get? How much we get? 6 by 2. So here is forming what is that? 3. This is already we discussed in FCC. Okay. The next one, the number of atoms inside the unit cell. What is that? It's a 4 atoms. It's not sharing any of atoms because it's a sublattice atoms. Right? The one cubical formation or one unit cell atoms, it will be shared by near. But sublattice, it's not sharing any atoms of nearby the unit cell. So it's a form of full of 4 atoms. We get it. What is that? 8. So this is called a base sublattice in a phase. So 8. Next one. So this is the calculation. Right? How we get that the final APF. So look at that. This is corner, it's clear, and this is base, right? 6. Then this is sublattice of base. What is that? The 4 atoms, right? It's not sharing any types of atoms. So it starts from this triangle, right? So the X, Y, right, and Z. All the sides we know that it's an A by 4 because we take it in a sublattice formation only, not a lattice. Lattice becomes an A, right? I think we have discussed in the previous topic of interplanar distance, right? D is equal to what we get? D is equal to A divided by root of H squared plus K squared plus L squared. This all is similar in distance. This is interplanar distance, and what is A? A is a lattice constant, right? A is a lattice constant. So here the A is a side or lattice constant, but here it's a sublattice. It's a quadratical formation. So we get all the sides from it. Sublattice is A by 4. So we know that what is that? X W then WY plus YZ is equal to XZ. Sorry, XY. Right? XY. So the A by 4 is a power of 3 times. XZ. What is XZ? Is equal to 2R. Here becomes mistake. The table is correct, but the printed is mistake. Are you clear? We take the hypothesis formation of XZ. The XZ equal to what is that? 2R. 2R means it's a one full of atom. R we know that it's atomic radius. 2R means it's a diameter. Diameter means it's a full of atoms. Are you clear? So the 2R squared equal to what is that? 3A squared divided by 60. Are you clear? The next one, 4R squared equal to 3A squared by 16. R squared equal to what is that? That's all. 3A squared divided by 4 into 16. 64. Then atomic radius R equal to root 3. Then A divided by 8. 8. Right? Then we substitute in that APF. Right? APF we get what is that? This is small b, capital B. Small b means volume of the what is that? Sublattice. That means the number of atoms per unit cell into volume of the atom divided by volume of the unit cell. Volume of the unit cell we take in cubical structure. So the denominator is forming what is that? Cubical structure formation. That means this is A cube. Right? Another 8, 4 by 3 pi, right? R value is this is root 3 A divided by 8 to the cube. Right? So the 3 and 8 cube is formed in denominator. Right? So the final answer we get what is that? Yes, 0.34. We know that the carbon is easily broke the structure. Right? So that's why we say the final conclusion we get from the based on the APF value of 0.34, the structure will be forming loosely packed structure. Right? So the value of APF, we have given the conclusion of the structure from this conclusion. Right? That's all from dimension. Thank you.